Hi everyone, welcome to this course on machine learning. If you're here, I expect you to have some interest in machine learning. Perhaps you want to get started with it, or perhaps you want to refresh your memory on some fundamental concepts. Whatever your reason, I'm happy to guide you through the course. Machine learning is a vast field full of math, algorithms, and computer science. To help you navigate it, I will start by introducing some fundamental concepts and ideas before delving into the details. So sit back and let's explore together what machine learning is all about. Let's start by asking the question, what is machine learning? We will discuss this question in more detail later, but for now, we can say that machine learning is a type of artificial intelligence where computers learn from experience. That is, they learn from data. In other words, machine learning is a type of programming where the program learns from past behavior and adapts accordingly. It is a way to build systems that can handle situations where we don't have a lot of prior knowledge. Why do we need machine learning? Well, first of all, we live in an age of data. We are generating more data every day and storing it on hard drives, and we can use all this data to build systems that can learn from it and make decisions. Secondly, there are many tasks that are difficult or impossible to do today because they require human intelligence. For example, understanding natural language or recognizing faces. But if we had systems that could learn from experience, then they could potentially do these tasks. Finally, having systems that can learn from experience could lead to new discoveries and insights. After all, when you look at enough data, you might find something that nobody has ever seen before. In this course, we will focus on the fundamentals of machine learning. This includes understanding different types of machine learning algorithms and how to apply them to real-world problems. We will also cover some basic concepts such as bias-variance trade-off, overfitting, and underfitting. The importance of machine learning is difficult to overstate. It is one of the most important developments in computer science, and it has the potential to change our world in many ways. Machine learning is being used today in many areas, including healthcare, finance, retail, transportation, and manufacturing. In healthcare, for example, machine learning is being used to diagnose diseases, develop new treatments, and monitor patients. In finance, it is being used to detect fraud, manage risk, and optimize investments. In retail and e-commerce, it is being used to personalize recommendations, optimize pricing, and target marketing. In transportation, machine learning is powering self-driving cars, and in manufacturing, it is being used to improve quality control and reduce waste. These are just a few examples of the many ways that machine learning is being applied today, and we can expect even more innovative uses to emerge in the future. Now let's dive into some more technical details. One way to think about machine learning is as a set of tools for building systems that improve automatically through experience. Experience in this case means that the system is exposed to some data, and it uses that data to improve its performance. In more technical terms, a machine learning algorithm is a function that maps input data to output labels. The input data is often referred to as the features, and the output labels are often referred to as the targets or classes. A simple example of an ML algorithm is a decision tree, which is a flowchart-like structure that uses a series of questions to classify data into different categories. Another common ML algorithm is a support vector machine, which uses a hyperplane to separate data into different categories. One of the key ideas behind machine learning is that the algorithm should be able to generalize well to new data. Generalization means that the algorithm should not simply memorize the training data, but should be able to make accurate predictions on new, unseen data. This is a very important concept in machine learning because it ensures that the algorithm is robust and reliable. There are two main types of machine learning, supervised and unsupervised. In supervised learning, the algorithm is trained on a labeled dataset, which means that each data point has both an input feature and a corresponding output label. The goal of supervised learning is to learn a function that maps input features to output labels. Supervised learning is often used for tasks such as classification and regression. Classification is the task of assigning a data point to a predefined set of categories. Regression is the task of predicting a continuous target variable. On the other hand, in unsupervised learning, the algorithm is not given any labels and must discover the underlying structure or patterns in the data on its own. The goal of unsupervised learning is to find clusters of similar data points or to reduce the dimensionality of the data while preserving its important features. Unsupervised learning is often used for tasks such as clustering and dimensionality reduction. Another key concept in machine learning is the notion of a model. A model is a representation of the data that captures the underlying patterns and relationships. The goal of machine learning is to find a model that is both accurate and generalizes well to new data. Model accuracy is typically measured using a variety of metrics such as mean squared error, root mean squared error, and R-squared. The best model is the one that minimizes these metrics. However, it is important to note that there is a trade-off between accuracy and generalization. A model that is too complex may be able to fit the training data very well, but it may not generalize well to new data. On the other hand, a model that is too simple may not be able to capture the underlying patterns in the data, leading to poor performance. This is known as the bias-variance trade-off. To understand this concept further, consider the following scenario. Suppose you are trying to fit a curve to a set of data points and you have two options, a straight line or a polynomial curve of degree n. The straight line represents a simple model, while the polynomial curve is a more complex model. If you choose the polynomial curve, it may fit the training data very well, but it may not generalize well to new data. This is because the polynomial curve has more degrees of freedom and is more susceptible to the noise in the data. On the other hand, if you choose the straight line, it may not fit the training data as well, but it may generalize better to new data. This is because the straight line is less susceptible to the noise in the data and is more robust. Another important aspect of machine learning is the notion of overfitting and underfitting. Overfitting occurs when a model is too complex and fits the training data very closely. This can lead to poor generalization, as the model is essentially memorizing the training data rather than learning the underlying patterns. Underfitting occurs when a model is too simple to capture the underlying patterns in the data, leading to poor performance. The goal of machine learning is to find the right balance between overfitting and underfitting. This is known as the bias-variance trade-off, and it is one of the fundamental concepts in machine learning. Finally, let's talk about some of the popular algorithms used in machine learning. As we mentioned earlier, decision trees are a popular choice for both classification and regression tasks. They are easy to interpret and can handle both categorical and numerical data. Support vector machines, on the other hand, are another popular algorithm for classification tasks. They are particularly useful when the data is not linearly separable, and neural networks, which are inspired by the structure of the human brain, are capable of learning complex nonlinear relationships in the data, and are particularly useful for tasks such as image recognition and natural language processing. We will cover all these topics and more in this course. We will discuss the pros and cons of different machine learning algorithms and show you how to apply them to real-world problems. In summary, machine learning is a powerful tool for building intelligent systems that can improve automatically through experience. It is based on the idea that computers can learn from data and make decisions based on that learning. Machine learning is being used today in many areas, and it has the potential to change our world in many ways. So that was a quick introduction to machine learning. In the next video, we will delve deeper into some of the fundamental concepts and ideas. Make sure to subscribe if you haven't already so you don't miss out on future videos. See you in the next one.